right, class. Welcome to part 2 of the 5.1a lesson video. Now we're going to do something that's actually not that bad, but it is something that you need to practice, and it is rewriting something from or rewriting a number to exponential form. Okay. What this really boils down to, class, is can you find the prime factorization of the number? And you kind of have to know what the base should be. Over time, class, when you get more comfortable with the numbers, you'll realize that they probably will be either a base of two, a base of potentially three, or a base of maybe five or seven. Notice that these bases have to be prime, right? So you take a look at 128. Yeah, you can divide 128 by 4, but really you should think of it as 2, right? So I'm going to go ahead and factor it as 64 and 2, and 64 can be 32 and 2, and you can keep going. You'll see that 128 is going to be clean for a base of 2 because 32 is really just let's do this as 16 times 2. And then 16 is going to be 4 times 4, which you could see is another 2, 2, 2, 2. So this does take a little bit of time. And then once I have everything in prime form, there's how many 2's do you have? I actually have 7 2's, right? So 128 is literally 2 to the 7th power. Okay. Again, over time, you will get used to it. I think some people realize that 32 is also, 2 to the 5th power, because 2 to the 5th power is literally 2 times 2 times 2 times 2 times 2. And you can see that that's going to end up giving you that 32. Okay. When you see something like 8, you know that it has to be a base of 2. You know that 2 to the 3rd power is 8. However, this is negative 8. So this can't just be 2 to the 3rd. And really, you attach the negative and you can make it negative 2 to the 3rd. And that will give you negative 8. And actually, this will also give you negative 8. So it could be either negative 2 to the 3rd or negative 2 to the 3rd power. They will all, because this is an odd exponent, you will get that negative still. Okay, 343, not as obvious. Definitely a little bit on the challenging side. I think we think of 3 immediately, but unfortunately, it is actually not 3, right? Like if you want to think of 3, you can think of it as, 3 times 3 times 3 times 3. Let's just have fun with this and see what it is. This is actually 9 times 9, which is 81. 81 times 3 is actually 243. And you can see that, wait a minute, I tried my best to use 3, and yet this number is nowhere near a factor of 343. So this is where you have to keep going on your journey, right? This is we hit a wall. So 3 is not the correct base. The answer, actually, class, is 7 to the 3rd power. I know that's crazy, but 7 times 7 is 49. And then 49 times 7 is actually 343. So again, with time, you will understand and you will be able to get it a little bit faster. What's cool though is you can see that all this work for 243 actually works for number 12, right? So number 12 is going to be 243, but there is a negative, and so we're going to write this as negative 3 to the 5th power. Okay. Let's move on. It says, number 14 says, write an exponential expression with negative 1 as its base that will result in a positive product. So you need negative 1 as your base, and you need to have an exponent that will make this result a positive product. Well, as you heard in my previous explanation, we need to basically put an even number as the exponent, because an even number of negatives will result in um, an even amount of negatives will result in a positive product. So it really just means -1 to any even number. Okay. And if you want a negative product, then you can just write -1 to any odd number, right? And that will result in an odd amount of negatives, which will result in a negative. Result in negative, right? That's why we call it odd and even functions. Okay, moving on. Let's go to the last page of this lesson. And it's really just practicing your skills of exponential functions. Determine if the equations are true or false. This is a good time for you to just practice. Sometimes, they don't always have to be true. They don't always have to be false. Sometimes they can be true and sometimes they can be false, especially if they have a variable in it. But this one is always hilarious to me because 3 to the 5th power, why in the world would that ever be 15, right? So 3 to the 5th power is this, which hopefully you start to kind of memorize as 81 times 3, which is 243, right? Remember, if you're raising something to the 5th power, that is, I mean, as long as your base is decent, that's going to be a big number, okay? Now, -2 to the 5th power, well, -2 is not that big, but you do know that it's still this, right? And that ends up being 4 times 4 times -2, which ends up being -32. So I should have said this is false. This is true. -6 squared equals 36. We talked about this in part 1. This is a huge point. You please put a star next to this one. -6 squared is technically -1 times 6 times 6, right? So this is actually going to be -36. So technically this is false. It is not 36. And you would say the negative is not part of the base and must not be squared, right? And is not squared. Okay. It's really, really important that we understand that. So then 19, it really just, that's a continuation, an extension of this topic. -4 squared, is that really the same as -4 squared with the negative kind of on the outside with no parentheses? Again, you could see that -4 squared is -4 times -4. However, -4 squared here is going to equal -1 times 4 times 4. So I know they look very, very similar, but they are not exactly the same. And you will end up getting 16 for the first one. The other one is going to be -16. Okay, so please, please be careful with something, especially when they're even functions. When they're odd functions and this is a cube, a 3 instead of a 2, then you actually realize that they both have the same output, which is actually the next question, number 20. Okay, so I'm going to move further down and switch gears to something like 22 to 27. This is really important for you to use parentheses when you plug in. I've been stressing the entire year, and hopefully your previous teachers have been stressing this as well. Whenever you plug in a value into a variable, you must always use parentheses, okay? So I'm going to write that one more time. Always use parentheses when plugging in your value into the variable. Okay, this is really, really important because it allows you to follow the order of operations. Okay, so let's take a look. So 22 says negative x squared. Okay, really, negative x squared is this class. That's all it's saying. It's saying negative whatever your x is squared. Okay, so I'm now going to plug in my x and realize that my x is negative 3. Okay, now a lot of people think that I should do the negative and the negative 3 to make that positive 3. Why is that a terrible, terrible route? Well, it's because it's not following the order of operations again, right? Remember, the order of operations says that we must perform the exponent operation first. So you must do this first before you ever even think about the negative. The negative is technically multiplication. Okay, so you gotta be careful here. Negative 3 squared, if I just look at it like that, I know it's 9 because it's negative 3 times negative 3, and that's 9. And then you attach the negative. So this is going to be negative 9. Okay, be careful. Follow my guidance with how I plug in. So like 5x squared minus 5x, I like to go like this. I like to really, really emphasize that I'm plugging into x. And then I plug it in like this, negative 3, negative 3. You gotta be careful here, right? My attention should always be on this act first because that's the order of operations, okay? Then, obviously, the steps after that will be considered multiplication. Okay, so this is negative 3 squared, which is 9. 9 times 5 is 45. And then negative 5 and negative 3 is 15. So it's just plus 15. The answer is 60. Okay. Gotta practice this, okay? You can't take the shortcuts and just think you know this because it looks easy. There's so many subtle things that you can do to accidentally miscalculate. Okay, 24 is a little bit intimidating because there's like so much going on, but I'm gonna go ahead and write it as parentheses negative 3 squared plus 4 all over negative parentheses negative 3 squared plus 4. It looks so similar to the top and the bottom are just kind of mind-blowing, like what am I doing, right? But really you can kind of think of it as I need to now this is where parentheses comes in, right? You now have the ability to do the parentheses first. You don't do the exponent here because the parentheses can be simplified. That's actually a positive 3, right? A positive 3 squared is 9. 9 plus 4 is pretty much 13. Here, the bottom denominator, you see it's negative 3 squared, which I do first because now the negative is not part of, like, it's not the same as the numerator, right? So I don't have the opportunity to do that first anymore. You can see that they're different. Okay, so this is 9, right? This is 9, and then the negative is attached after, so it's negative 9, and then negative 9 plus 4. Well, that's different than 9 plus 4, right? So 9 plus 4 is 13, and then negative 9 plus 4 is negative 5. Final answer is should be getting negative 13 over 5. Okay, we're going to go ahead and talk about 25 through 27 in class. I hope you enjoyed this video. You can see that math is something that you need to practice often. And we're ramping up the order of operations, expressions, and calculations. And exponents are not that bad, but you do need to get used to the whole kind of process of it all. Okay. See you next time.